Hi guys. Tomorrow in class you guys are going to look at the volume of prisms and pyramids. So let's start by talking about what volume is. Volume is the space an object, in this case a 3D shape, takes up. Now each one of the prisms we're about to see is going to have a different formula. But the general formula for any prism is B times H. But what I want you to look at here is that it's a capital B and a capital H. That's because capital B actually stands for the area of the base, and H stands for the height of the prism itself from one edge of the base to the other. So each one of these prisms has their own formula. Rectangular prisms are by far the easiest. It is volume is equal to length times width times height. Notice that length and width are lowercase, height is that uppercase, because the length times width, this portion is that area of the base. Then H, how tall it is. For a triangular prism, it's the same thing. Area of the base times the height, but how do you find the area of a triangle? Base times height divided by 2. That's that big B times big height. Very important that we have little h and big H. That's just the height of the triangle. The capital H is the height of the prism. Trapezoidal prisms, volume is equal to base 1 plus base 2 times the height of the trapezoid divided by 2 times big height. And last but not least, our regular polygons. So any of our, pentagons, hexagons, octagon kind of shapes there. The volume is 1/2 the apothem times the perimeter times the height of the prism itself. Now, on any of these formulas that have the divide by 2, we are able to multiply these three numbers first and divide the entire answer by 2. So we could actually have this all over 2, all over 2. That's because everybody's multiplying, and division is just the opposite of multiplication. Or you can think about it as multiplying by 1/2, which is exactly what's listed there. All right, we want to find the volume of these prisms. The first thing we're going to do, and in order to show full work on our homework, we want to write down the formula that we intend to use. Length times width times height. On a rectangular prism, the length, the width, and the height are all interchanged. So we can have 5 times 4 times 5, which then gives us our volume, as 5 times 4 gives you 20. 20 times 5 gets you 100 inches. And then with volume, we are cubed units. All right, let's look at this next rectangular prism over here. Because it's a rectangular prism, the formula that we intend to use, length times width times height, it might seem like a really stupid, or like you might feel, why are you asking us to write down the formula, Carlisle? Well, in these initial problems, you're right. It's not really that needed. But far too often do I see problems later on in math, later on in geometry, where if you don't write this formula, then you don't see where you can put some of the information you know to solve it in methods that you probably wouldn't see until you had that formula written out. So I want you to get into the habit early that you should always write the formula you intend to use. In this case, the length I'm going to call 6. The width I'm going to call 3. The height I'm going to say is 2. So 6 times 3 is 18. 18 times 2 gets me, I meant to grab blue right there. 18 times 2 gets you 36 miles cubed worth of volume. And that's our rectangular prisms. Let's take a look at our triangular prisms. So with the triangular prism, the formula we intend to use is base times height divided by 2. The parentheses aren't technically needed, but I'm going to write it because that's how I wrote it above. What I need to find for our triangle is that little base and the little height. So the 2.2 right there, that's the height of the triangle. So that's little h right there. And it's connected to this dotted line right there. So that's my base. So what I really have is 11 times 2.2 all over 2. And then the height of my prism, how far is it from the bottom triangle to the top triangle? So the big height is over here. It's the 4. And all I have to do is multiply all of those. So I'm going to grab my calculator here. I'm going to turn off the 3 screens. I'm going to go back to the home screen, and I'm going to take 11 times 2.2 times 4, divide that number by 2, and that is our area, 48.4. Now you might be thinking, well, couldn't we just multiply by 2 and skip the dividing by 2 phase? Yes, you can always speed up the process and cut like this 2 and that 4 in half. But I want you to get in the habit of always having divide by 2. Because again, through processes, you might have to remember to multiply by 2 if we ever have to use these problems backwards. All right, let's look at the triangular prism to its right. Volume, I'm going to rewrite the equation to have all of the letters on the top and divide everybody by 2. Just another way to do this problem. Our right angle symbol right there, so that tells us that the base can be 5, the height can be 12, which then means the total height from one triangle to the other triangle, the height of the prism, is 11. Divided by 2. All right, so let's find the volume of this. So, grab my calculator again, clear it out. I'm going to take 5 times 12 times 11, divide that by 2, and we get 330 kilometers cubed. While I had that up on the screen, I wrote it on our page right there. The next 2 shapes are our trapezoidal prisms. So let's start with this one right here on the left. Trapezoidal prism. Volume is equal to base 1 plus base 2 times the height, little height, times big height, divided by 2. So again, I wrote it in kind of the new style. The only thing you got to be careful with the trapezoidal prism is that this addition has to happen before we do any multiplication at all. So we have to take that 12, add the 7, multiply the height of the prism 5, multiply the height of the trapezoid, times the height of the prism, all divided by 2. Again, the height of your prism is the distance from one base to the other. So how far is it from the bottom trapezoid to the top trapezoid? So I'm going to grab my calculator one more time. 12 plus 7 times 5 times 4 divided by 2. We end up with 190 for our volume. I did not specify units in the problem, so we're going to put units cubed. Let's take a look at this trapezoidal prism. Base 1 plus base 2 times the height of the trapezoid times the height of the prism, all divided by 2. Taking a look at the picture over here, looks like my first base, I'm going to say, is 14. My other base is 4. Height of the trapezoid is 8. The big height is 20. We're going to divide all that by 2. Let's go find the volume of this trapezoidal prism. Grab my calculator. I'm going to take 14 plus 4. Enter. Times 8 times 20 divided by 2. So the volume is 1,440 units cubed. The last shape we're going to look at on the front side of these notes is this prism right here. Let me get my cursor out of this frame there. It is a hexagonal prism, and they have told us our side length right here. The 10 corresponds to the height of our prism. What we need to do is we need to find the apothem. All right, so to find the apothem, I'm going to write the A right there. We need the perimeter. Well, 4 times the 6. We've got 24 centimeters for our perimeter, and the height of the prism itself is 10. So we're good to go there. Off to the side, I'm going to draw in our triangle. That's a triangle that would be built right there. Half the distance is 2. Because it's a hexagon, I know that the interior angle right there is 120, which makes this 60, which makes that 30. So that makes it really nice to go, oh look, 30, 60, 90 triangle. This length right here ends up being 4, but nobody cares. This height, our apothem, that's the height we do care about, is 2 root 3. So I'm going to record that right there. Now from here we can decide to stay in radical form, or we can decide to multiply it out and get a decimal. Because I don't want to have to use my calculator any more than I actually have to, and I know I've used it sometimes when I probably didn't need to, I just want to make sure I get my calculations correct. The volume is 1/2 the apothem times the perimeter times the height. So our volume is 1/2 times 2 root 3 times 24 times 10. So we end up with 240, which times the 8 gets us 480. I'd cut that in half. I'm back to having 240 root 3 centimeters cubed worth of volume. And that is how you find the volume of prisms.